we're gonna just extend what we did yesterday just a bit. Okay, very quick review of what we talked about yesterday. We looked at inequalities and how to solve inequalities. And we said that solving inequalities was just like solving equations, except there was one exception, one rule that's a little bit different. What's that? We add or subtract things to both sides, just like we normally would. We could multiply or divide both sides of an inequality by a positive number and nothing changes, but what's the difference? What's the thing we have to be careful of? Yes, ma'am? Good. If you multiply or divide both sides of an inequality by a negative, which you're going to end up doing to solve for x sometimes, you have to flip the inequality sign, right? That's really important. Okay, so along those lines, now if we look at this case right here, go up one. Okay, I'm going to solve for x, but I've got two x's there, right? So what do I have to do first? Can't isolate x yet because there are two x's. I have to be able to point to a single x. Say it again. Okay, good. We're going to push the x's to one side, and we want to push them to the right. How come? Good. And it's especially important here because that last rule we talked about. If we subtract 7x from both sides, I'm going to get a positive number of x's, which is great because if I get a negative number, then when I end up dividing by the negative, I got to remember to flip the signs, and that is far and away the most common mistake people make. So let's avoid even having to worry about it and just subtract 7x from both sides so I get a positive coefficient, right? Now what? Add 12 to both sides. Now what? Good. Divide by 3. And I get that answer. Now, how do I say that answer? Somebody raise your hand. Yes, sir.
X is less than or equal to 7.
Good. X is less than or equal to 7. You always start with the variable, don't you? That's not written in the best possible way then, is it? How could I maybe change the way that's written so it's a little better? Flip it around. Good. We could rewrite that as x is less than or equal to 7 the way we say it, right? Good. Okay. What if I want to graph that? What am I gonna do to graph that? 2 steps. First step is what? Okay, open or closed? Closed. How come? Good, because we're including the endpoint, the equal sign, right? I'm gonna put a closed circle on 7 and shade in which direction if x is less than or equal to 7? Left. Okay, good. Remember, this is describing if an ant can walk in this region, then the ant could step on 7 or walk to the left, right? Okay. All right, so what about this compound inequality? There's 2 kinds of compound inequalities. There's a conjunctive and inequality, or a disjunctive or inequality, and this is what they look like. Okay? An and inequality always looks like 2 inequalities joined into one. And an or inequality is literally just 2 separate inequalities that we deal with separately. This one's easy to say, the or. I would say that just like it looks. X is less than or equal to -2, or x is greater than 4. No big deal. Now, this is a little more of a challenge. Anybody care to take a stab at that, how I might say that correctly? Yes?
X is greater than -3, but x is better equal to
99.999% right. One little slight mistake there. You didn't use the all-important word, the and. Try it again, using an and.
x is greater than 3 and less than or equal to 1.
Perfect. Actually, always start with the variable, right? X is less or greater than -3 and less than or equal to 1. Okay, now let's look at the graphs of these. The graphs are really important. When we're looking at an and inequality, the graphs always have a certain kind of look. We look at an or compound inequality, they have a very different look. So what am I going to do to graph? Let's focus on, for a moment, just the left part of that compound inequality. So what's that going to look like? X is greater than -3. I got to put a open circle on -3, okay? And I'm going to shade in which direction? To the right. Good, because I'm greater than. So I'm going to shade this way, right? Okay, now what about the other side? Let's look at the right side of that inequality. X is less than or equal to 1. What's that going to look like? Going to put a
Close.
closed dot, good. Closed dot on 1 and shade to the left. Okay, and then what's going to happen when I combine both of those graphs in one? Don't I just get something like that? Make sense? Okay, now so describe the places where the ant could walk there. If he has to walk only on that solution set, those are the only places he can walk on that number line, where can he walk?
1 to -2.
Oh, 1 to -2. Could he walk on -2.5? He could, couldn't he? Could he walk on -2.9? Could he walk on -2.9999999999999? He could, couldn't he? Can he walk on -3?
No.
No, he can't. He can't step on -3, but he can step right up to that. It'd be like me, if I cut, did I do the example with the door yesterday?
Yes.
Yeah, it's the same kind of deal. If I cut my distance to the door or the wall in half, I never actually get to the wall, but the wall is the limit of my motion. That's the end point, right? The boundary. Same thing here. So that ant is kind of stuck between these two endpoints. Now he can step on the right endpoint, but not the left endpoint, right? I want you to notice something here. I know these ant analogies are, that's a little weird, but they work really well in a way. They make you think visually about this. When I'm describing where the ant can walk, notice that I have to use both endpoints to describe where he's limited to be. Does that make sense? I can say that he has to walk to the right of -3 and on or to the left of +1. I have to use both endpoints to describe that region. That's an and inequality because I need them both at the same time. They're both literally pinching that ant between the endpoints. You can see that when I write these compound inequalities properly, when I write the smaller number on the left and the bigger number on the right, the -3 corresponds to the left boundary and the +1 corresponds to the right boundary, and it's a trapping situation between the two. Okay? Now, what about the graph of this guy over here? Let's take a look at the left part. X is less than or equal to -2. How am I going to graph that? I'm going to put a closed circle on -2. Okay, and I'm going left. Okay, what about the other side? X is greater than 4. What's that going to look like? Okay, this time I'm going to have an open circle on 4, and I'm going graphing to the right. Agreed? Okay, now this time, when we're describing where the ant can walk, they're two separate, distinctly different regions, right? Either the ant is going to be to the left of or on the left endpoint, or he's going to be to the right of the right endpoint. Okay, now notice this time that when I'm describing where the ant can be, I'm using only one boundary at a time. Either I'm using this boundary or this boundary. When I'm talking about this red region over here, I'm only worried about the left boundary. I don't even need to worry about the 4, do I? When I'm talking about the green region over there, I'm only worried about that right endpoint. The left one has no bearing. So it's an or inequality, and that makes sense. Either the ant is there or he's there. He can't be on both at the same time. It's a choice, one or the other, right? Now when you think about the graph of that, it's different. It's not a trapped region. It's regions out there, separate regions. If I'm rowing towards you in a boat, in a rowboat, where are the oars sticking? People are laughing at me. If I'm rowing towards you in a rowboat, where do the oars stick? Out to the side. It's like the oars on a boat. So an or inequality is like the oars on a boat. The arrows always go out to the side, right? Make sense? Okay, good way to remember it. Okay, so and is between, right? And you got to pay attention to the endpoints, and you guys are good at that. Those could vary, but the and part always means you're graphing in between. And or, think oars on a boat, out to the sides. Okay, good. Now, how do you solve these guys? If we're dealing with a compound inequality, what do I do to solve a compound inequality? Well, it's the same kind of stuff as before, but what's different about this? is, I wanna get the t by itself. I don't just have two sides of an equation or an inequality, I've got three parts that I have to deal with, but I can do them all at the same time if it's an and compound inequality. What's the only step I need to get the t by itself? Subtract 4. I just have to do it to all three parts. Right? So I'm going to get a negative 13 over here, a t in the middle, and a 6 over here. And you always want to ask yourself, now do I need to flip those inequality signs? No. I don't need to because I didn't multiply or divide by a negative. But you always want to do a little self-check there. Just ask yourself, do I got to flip them? Usually you don't, but maybe you do sometimes. Okay? So if I graph it, it just looks like the region in between negative 13 and positive 6, and I'm just putting open circles there, right? Okay. If I'm solving, this is not quite right, I got one more after this. If I'm solving an OR inequality, it's simple. You just deal with them one at a time like you normally would, like we did yesterday. So on the left one, I'm just going to subtract 9 first and then divide by negative 6. Good. On the right one, I'm going to, first I'm going to add 8 and then divide by, okay. Now, what do I have to be careful of in both cases there? Got to flip the sign because I'm dividing by negatives. So there's first step, divide by the negatives, it flips them around. Okay? Okay, now I want you to notice something about this. These are not written really in the best way. You'll see this sometimes, and this isn't a huge, great big deal, but in Moodle it is going to be. When you enter this stuff in Moodle, I specifically want you to get in the habit of writing the inequalities just like you would look at a graph on a number line. So if I look at the graph of this guy, I want you to notice something. Okay, we're going to graph an open circle at negative 7. We're going to shade to the left. Open circle at x equals 1 and shade to the right. But we've got this mixed up. We don't have the numbers in the right spots. They're crisscrossing. That 1 refers to the right boundary, and the negative 7 refers to the left boundary. So we'd really rather turn that whole thing around. We'd really rather write that as x is less than negative 7 or x is greater than 1. Isn't that better? Because then the negative 7 deals with the left boundary and the positive 1 deals with the right boundary. Make sense? On Moodle, I will force you to do that. You're only going to get choices to do it that way. Okay? One last example here. Let's look at this guy. Okay? Now, what are the two steps I'm going to do here to get that x by itself? First, I'm going to add 1, and then I'm going to divide by negative 2. Agreed? Divide by negative 2, and then I get the x by itself. And that's my goal, right? When I'm solving for a variable, I'm isolating it. So let's do those two things. First, we'll add 1. Okay, and we'll see what happens to all three parts. On the left, I get 0. In the middle, I get negative 2x, because the 1's cancel. Good. And on the right, I get 10. Okay, have the inequality signs flipped yet? What do you think? Raise your hand if you think they have flipped. Raise your hand if you say they have not flipped yet. Oh, okay, good. Good. They haven't yet, have they? Now, they still may, but they haven't yet. Okay, now what? Divide by negative 2. So we'll do that to all three parts. Okay, let's see what we get. So over here, now what is 0 divided by negative 2?
0.
It's just 0, yeah. Some people were wondering, they run into some problems like this, and they're thinking, oh, what do you do? 0 divided by any non-zero number is just 0. Now, what is it that I can't do with 0 in division? I can't divide by 0. The 0 can't be on the bottom, but 0 can be on the top. That's no problem. This just gives me 0. The negative 2's cancel, and I get my x, right? And what's 10 divided by negative 2? Negative 5. Okay, what do I have to do here, though? Gotta flip the signs. Good. So now watch what happens. When I flip those signs, I think that was supposed to be an equal to, wasn't it? So it looks like that. Is that a good way to leave it? it's correct, strictly speaking, but there's something that's not good about the way that answer is written. Say it again. The zero's fine by itself, but there's something about the position of the zero that's not good. If I were to graph this inequality, think what the inequality looks like. I get dots at 0 and -5. Which one's open? 0. Okay, I get an open dash at 0 and a closed, or open dot, and a closed dot at -5, right? So there's my 0, there's my -5. I've got, let me say, closed and open, and it's an and inequality, so what am I doing? Mention them, right? Okay? But notice that I got the numbers crisscrossed again. I don't want that, right? The 0 is referring to the right end point, and the -5 is referring to the left. Now this one's a little trickier. How do I take that whole thing, this whole inequality, and flip it around, twist it around? Okay, imagine that I've got this thing written on a piece of glass. Here's what I'm going to do. It's written on the piece of glass, right? I'm going to do that with it. You see that? I got the glass. I'm going to do that with it. What does it look like after I do that? Okay, go say it louder, Brittany.
-5 is less than or equal to.
Okay, good. So now look what it does. When I turn the glass around, now I've got the -5 over there. I've got the 0 up there. And I got the x in the middle. But now the inequality signs all get flipped, right? So this greater than or equal to is between the x and the -5, but it gets flipped around, right? And that less than sign is between the x and the 0, but now it gets flipped around. Now that's a good way to write it, right? That makes sense? Now I've got the -5 on the left where it belongs, and I move along the number line to the right to get to 0. Okay? Make sense? Yes, ma'am?
Just move it only.
Only we'll take it that way. Yeah. Okay, we good? 205, new assignment's up. Good job.